All right, welcome viewers. I believe I have 267 viewers as of today. I want to welcome you guys to an introduction to trigonometry, which is the third day of Unit 7, right triangles. This whole unit is on right triangles. The first lesson was on Pythagorean theorem. Pythagorean theorem is used when you have a right triangle. Phone should be away. When you have a right triangle and you're given the lengths of two sides and you're asked to find the third side. The next lesson was special right triangles. So now, in that lesson, we had two types of right triangles that were special. One was a 45-45-90 triangle. The other was a 30-60-90 triangle. If those angles are either 45-45-90 or 30-60-90, we have those relationships that we have memorized, that we don't have to go through the Pythagorean theorem or do any work because we have those relationships memorized and they're quick. But those relationships are only for those two types of special right triangles. The third lesson is today. Sometimes we have a different type of information. Sometimes we're given the length of one side and we're asked to find the measure of an angle, or we're given the measure of one of the other angles besides the 90 degrees and the length of one of the sides, and we're asked to find a measure of another side. So it's not a special right triangle, and we don't know the lengths of two sides. Come get a cameo in my video. Miss Gresh, come on, people want to see you. What if Joey's watching? She just walked out. Okay, so that's what we're going to start with today. I also want to show you guys, I'm wearing my Give Blood t-shirt. We have a national crisis. Everyone needs to give blood. I'm wearing my stethoscope. I'm also wearing my doctor coat. This is from Unique. I know it's shocking. It's actually a pharmacist coat, but it's so fire, isn't it? And the students have fed me some things that doctors say. I'm going to say for you guys, and you tell me if it sounds legit coming from you, okay? Do you have any allergies? Okay, let me just check your heartbeat. Oh, all right, that's good. That's good. I mean, like, could I be on Chicago Med, right? Put comments in the chat or whatever it's called. All right, what are some other things I could say? What? The transplant was a success. It was. Okay. We need to keep you overnight for observation. What was the other one?
Does it hurt when I press here?
Okay, does it hurt when I press? Hold on. Does it hurt when I press here?
Can you please follow me to the second room on the right?
What? Please follow me to the second room on the right. The nurse will be in shortly. Well, there was one other. I feel like I'm doing a good job.
We haven't made a diagnosis yet, but we've ruled out cancer.
We haven't made a diagnosis yet, but it's not cancer.
I'm going to prescribe you some.
I'm going to prescribe you some antibiotics. Okay, so sorry. Let's get to some math. Okay, so here are the relationships, the trig relationships that we have to memorize. The best way we have found to memorize these relationships is with SOHCAHTOA. Okay, now there are different ways, and if you've learned it from a tutor a different way. My math teacher back in the day taught me how to memorize it using the first letters. Oscar has a heap of apples, and that's how we did it back in the day, but SOHCAHTOA seems to be the method for today. So the three trig relationships are sine, cosine, and tangent. The sine ratio is the opposite side over the hypotenuse. The cosine relationship is the adjacent side over the hypotenuse, and the tangent is the opposite side over the adjacent side. As soon as we look at these, we are going to do an example and just make sure we understand what the opposite, adjacent, and hypotenuse sides are and how to identify them. So if we're referencing this angle here, this side is opposite, this side is adjacent, and this side is the hypotenuse. The sine relationship is the opposite side over the hypotenuse. The cosine relationship is the adjacent side over the hypotenuse. And the tangent relationship is the adjacent side over the opposite side over the adjacent side. And these just need to be memorized. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So now if we're referencing the other angle, okay, this angle up here, now this side is opposite. This side stays the hypotenuse because it's across from the right angle. So we're going to go ahead and practice doing that first. I'm going to prescribe you some antibiotics. Do you have any allergies? Okay. Given the right triangle, label the opposite, adjacent, and the hypotenuse. Okay, so we are referencing this angle right here. That's a theta. It's one of the variables that they use to identify an angle. And sometimes they use x. They can really use whatever variable they want, but theta is used a lot for the measure of an angle. The hypotenuse is always in the same place. So let's go ahead and put an H where the hypotenuse is. The side opposite is over here, and the side adjacent is here. Now, if we were referencing this angle, the hypotenuse would stay in the same place, but the opposite side and the adjacent side would switch. Any questions on opposite and adjacent? Okay. So we are going to practice this. So go ahead and put sine, cosine, tangent up at the top. And see if you can match what we just did with the pictures. And then when you're finished, I'm going to give you about 30 seconds right now. Go to the next slide and check your answers. How are you feeling today? Tell me what's going on. When did this start? Yesterday? Okay. What else do they say?
What?
What else do doctors say?
I don't know. You're the one who goes to like the physical therapist all the time.
That's different. Physical therapist is different.
It's still a type of doctor.
I know, but
I used to
minor
work-
overuse injuries,
Yeah.
those don't count. I smashed my finger in between two weights this morning. My fingernails can be purple. It's good times. Here we go. So the sine relationship is opposite over hypotenuse. And if we're referencing this angle, this side is opposite, and this side is, I'm sorry. That's not right. Where's the hypotenuse? Oh yeah. Opposite, and that side is the hypotenuse. Adjacent over hypotenuse. Opposite over adjacent. How are we doing? We did practice this a little bit before the break. Now let's use numbers. Same concept. Using this triangle right here, sine, and this K, now they're telling you what angle to reference. Angle K. I'm taking this off. Angle K is here. The sine relationship is the opposite side over the hypotenuse. So that's 5 over 13. Give you a couple seconds to do the other one. Well, I'll show everybody my Give Blood t-shirt. This is from a drive, I think it was 2015, it might say on the back. Has all the schools that the drive was at, and Heritage High School's on the back, of course. So if you can give blood, please give blood. We are in a national crisis right now. So cosine is referencing angle K. Adjacent over hypotenuse. The tangent is opposite over adjacent. How are we doing? Okay, here's what these problems look like. So notice we've got a right triangle. We only know the length of one side, so we can't do Pythagorean theorem. It's also not special. unfortunately. It's not a 45, 45, 90 triangle, and it's not a 30, 60, 90. We've got this 70 degrees. However, we're also given the length of one side. We're asked to find the length of another side. We know nothing about the hypotenuse, and we are not asked to find it. Okay, so I'm gonna have to use this x and this 3. So, referencing this 70 degrees, this side, this x, is opposite that 70 degrees. And this 3 is adjacent. Which trig ratio uses opposite and adjacent? Might have to look back at the slide, but. Okay, tangent. So this is how we set this up. The tangent of 70 degrees, the tangent, and you're just gonna write TAN, and you're gonna put the 70 degrees in parentheses, should equal opposite side, which is x, over the adjacent side, which is 3. Now, if this were algebra 1, and you were given, I'm just gonna make up a number, I'm just gonna say 9 equals x over 3, okay? Back from algebra 1. How would you do this? This is this exact same thing. The tangent of 70, that's a number. How would you solve for this x? I know everybody knows, you guys are quiet today, so I'll just say it, to multiply both sides by 3. And that's what we're gonna do here in this problem up here. We're gonna multiply both sides by this 3. So let me erase all that. Didn't really leave myself a lot of room, but that's okay. Now all we have to do is type this into the calculator. So now we go to our calculator, our graphing calculator online, and we do 3 times. Now you can put the tangent function in one of 2 ways. You can go to the functions button and select tangent, or you can just type the letters TAN. But the function button will give you parentheses and remind you that you have to put the degrees inside the parentheses. If you just type in the letters TAN, you have to remember to put the parentheses. No big deal if you can do that. Tangent of 70 degrees times 3. All right, we are getting 8.24. The calculator has calculated this for us. The question says round to the nearest 10th. So we look at this problem and we say, all right, the 10th place is the 2. We have to look at the number after the 2 to determine whether it's going to stay a 2 or move round up to a 3. The number after the 2 is what we look at, that 4. Remember, it's 5 or above, give it a shove. 4 or below, let it go. That's a 4, so we're cutting it off, 8.2. Let's type it in. See if the computer likes it. 8.2. Whoops, there's a comma in there. Boom. Questions? That's it. That's all there is to trig. There's one more type of problem that's a little trickier. I think I'll show you that on the next problem. How long is my video? 13 minutes. Okay. I am going to switch this problem around. Okay? So I'm going to erase this 25 and make it an x. And I'm going to make this b a 20.2. You'll see why in a minute. I realized this last class. This is the other type of problem you'll get. So referencing this 36 degrees, okay, we are given this is the adjacent side and that's the hypotenuse. So I'm going to go ahead and set this up. Which trig ratio uses adjacent and hypotenuse? You got to look it up or have it memorized. Adjacent and hypotenuse is cosine. The cosine of 36 degrees equals adjacent over hypotenuse. The reason I switch these numbers and letters is because sometimes you will end up with a variable in your denominator, okay? And if you think about this from Algebra 1, we were solving for that denominator. What would you do? You can think of this as a proportion. Maybe I could write on the board. I'm gonna make something up. 9 equals, let's do 3 over x, okay? You can think of this a few different ways. Am I in the video? Yes, barely. Okay, you can think of this as cross multiplying. So 9 times x equals 3 times 1, and then you divide both sides by 9, and I know I'm standing in front of it. But you'd be getting, in your calculator, you do 3 divided by 9 to get the value for x. And that's how you'd solve this type of problem if you were thinking about it in terms of a proportion. However, there's a shortcut. Here's the shortcut. If you have a variable in your denominator, you don't have to go through all that. You can switch the location of the x and the 9. Leave the 3 where it's at. So this becomes x equals 3 over 9. Notice it's the same as if we went through all of this work. The other way you can think about it, and I know I've done a bunch of different ways here, but it doesn't really matter, is multiply both sides by x. That way you're still getting 9 times x equals 3, and then you're dividing both sides by 9. However you want to think about it, you are dividing, 3 divided by 9. Okay, so in this problem, if I want to do shortcut, I would switch the x and the cosine, and then take my calculator out. The last thing I want to show you, we're not going to do that in the calculator. The last thing I want to show you is on the calculator has a default of, it measures angles in degrees. You can see it's highlighted right there. If you wanted to change it to measure angles in another, oh my gosh, that was a former student that walked by, but I don't think it is. No, okay. In another unit called radians, and you'll need that in pre-calculus, you could just go ahead and switch it. But luckily for us in geometry, the default is degrees. All right, that's it for now. Thanks for coming out. We're glad you're starting to feel a little bit better, and we hope that you subscribe and like my channel. Like this video and subscribe. Okay, that's all. Peace out.